Hello, everyone. We are working through an introduction to statistical methods and data analysis by Longnecker. This is chapter 12, part 3. So up until this point in part 3, we've been talking about the overall F-test. So do all these variables taken together predict the response? What we're going to do now is talk about the partial F-test. In the partial F-test, we're really asking, do these additional variables predict the response given some subset of the variables are already in the model? So the difference between the overall F-test and the partial F-test, you really want to separate in your mind to become clear. The overall F-test says, do all of the variables predict Y? And the partial F-test says, do these additional variables predict Y given I have some subset of variables already in the model? Okay, so we're talking about the partial F-test. The full model is where you have the K predictors in your model. Beta 0 plus beta 1x1 plus beta gxg plus beta g plus 1 xg plus 1, all the way up to beta k xk plus epsilon. All right. The reduced model only has the first G variables. So the reduced model is a subset of that full model where we have Y equals beta 0 plus beta 1x1 plus all the way down to beta gxg plus epsilon. What we could do in this case is we could calculate an ANOVA table for the full model and also an ANOVA table for the reduced model. All right, let's look at the similarities. Let's look at the differences. Okay, so for the full model, degrees of freedom, right? We have K plus 1 predictors minus 1. So the degrees of freedom due to regression is K. The degrees of freedom due to error, well, that's N minus K plus 1. The degrees of freedom total, N minus 1. Now we fit the model and we get the Y hats. And for every observation, we can do the observed minus the predicted under that full model. And we can get our sum of squares regression, our sum of squares error, and our sum of squares total for the full model. We calculate the mean squares in the regular way. We take the sum of squares regression of the full model divided by K. That will give us our mean square due to regression under the full model. If we want the mean squared error under the full model, we take our sum of squares error based on the full model, divide by N minus K plus 1. The F-test statistic in this case is our MSR of the full model divided by our MSE of the full model. We can calculate the p-value by finding the probability that our test statistic falls beyond a certain value, assuming the null hypothesis is true. Similarly, we can calculate the ANOVA table of the reduced model. So in this case, we only have G predictors, right? So we have G plus 1 coefficients that we're trying to estimate. So our degrees of freedom is G plus 1 minus 1, which gives us G. The degrees of freedom for the error is N minus G plus 1. And the degrees of freedom total is still our N minus 1. We calculate our sum of squares based on the reduced model to get our sum of squares reduced, our sum of squares sum of squares of regression of the reduced model, the sum of squares error of the reduced model, and the sum of squares total. To calculate the mean squares, we're going to take our sum of squares of regression of our reduced model, divide by G, and then for our mean squared error, we're going to take the sum of squared error of the reduced model divided by the degrees of freedom of the error under the reduced model. We can calculate an F-test statistic of the reduced model as our mean square regression of the reduced model divided by our mean squared error of our reduced model. In this case, both of these ANOVA tables are giving us an overall F-test. In the first case, we're asking, are the K predictors predictive of Y? And now in the reduced model, we're saying, are the G predictors predictive of Y? Those two questions are the overall F-test. But if you want to ask the question, Are the additional predictors, G plus 1 up to K, predictive, given you already have G predictors in the model? Now you're asking the question of a partial F test. So the partial F test asks, are the G plus 1 up to K predictors, those additional predictors, are those additional predictors predictive of Y, given the G predictors are already in the model? Now you're doing a partial F test. All right, we're going to do more examples in future videos, but I hope you learned something today, and I'll see you next time.